smoke management and prescribed fire. Questions you should be able to answer by the end of this module include, what are the two major adverse impacts of smoke? What is an inversion layer and what happens to smoke that's caught within it? Which of the 6 dispersion categories from the Oklahoma dispersion model are good for prescribed burning? How can the fire prescription planner be used for prescribed burning? So we'll be able to answer these by the end of the module here. So let's first talk about smoke. And first of all, what does it consist of and what are the adverse impacts? Well, let's first look at what it consists of. Much of it is just carbon dioxide and water vapor, which in and of themselves are not harmful to human beings. But there's these other noxious gases such as carbon monoxide, hydrocarbons, nitrogen oxides. And then there's also these fine little particles that get released called particulate matter. And air pollution, people break them into 3 categories. What they call PM 2.5, that refers to diameters of 2.5 microns or less. This would be 2.5 to 10 micron diameters, and this would be those greater than 10 micron diameters. Now, the real dangerous PM diameters are this PM 2.5, and unfortunately, most of the particulate matter in smoke, 70% of it consists of these very small particles. So that says all other things, that you have in control, it's not good to breathe smoke. And if you have to be in it, to wear some type of mask or filtration device to prevent those particles from entering your lungs and so forth. But so from a health impact, smoke is bad. It has if it blows into a neighborhood where there's homes and people there, that's not good. Or if you who are doing the prescribed burn or fighting the wildfire breathe it, it's also not good. So that's one of the adverse impacts of smoke. Of course, the other one is the visibility impacts, and we saw this example earlier where these hay bales caught on fire and the smoke blew across the road and ended up killing two people. So one of the adverse effects, obviously, is the visibility impacts. Let's talk about the general phenomena of atmospheric dispersion. It's basically the ability of the atmosphere to horizontally and vertically disperse and dilute embedded gases and or particulate matter. In our case, smoke. Here's a diagram showing a side view of a smoke plume and a top view against different weather conditions and against different times of day. So let's first look at the typical daytime case. If you have a lot of sunshine, strong solar radiation, and light wind conditions, you get a lot of vertical dispersion because there's a lot of turbulence in the atmosphere induced by the heating, and you get these thermal eddies that go up and down and mix the smoke. And you get also good horizontal dispersion as a result. If you have a little less solar radiation with a little stronger winds, you still get good dispersion, but not as pronounced as in this case up here. And meteorologists typically call this an unstable atmosphere. During day or night, if you have overcast or strong winds or both, the dispersion is not as good as in these cases up here, and it looks like, from a side view, it looks like a half of a cone, ice cream cone or whatever. And meteorologists call this a coning plume. Air pollution people call it a coning plume, and if you look at it from the top view, it does look like a cone. These are typically called looping plumes because they look like they loop up and down and so forth. The nighttime case, if you have mostly cloudy skies with light winds or mostly clear skies with a little stronger winds, you get even less dispersion, both in the vertical and in the horizontal. And if you have a clear night with very light or calm winds, you get even worse dispersion. And air pollution meteorologists call this a fanning plume, because if you look at it from the side view, if you think of an old-fashioned woman's fan, it's very, thin from looking at from the side. So they call this a fanning plume. Does a little more meandering in the horizontal, but not as much good dispersion as in these cases up here. So those are the three main cases of plume behavior. So let's first look at the unstable atmosphere. And by the way, these cases here are associated with what meteorologists call a neutral atmosphere, and these cases are what meteorologists call a stable atmosphere. We won't go into the details of that at this point, but let's look at the first cases, the typical daytime case when you have an unstable atmosphere. This was a prescribed burn evidently going on in north of Stillwater on, looks like, I think it was OSU property actually. But you can see it was a day with a lot of sunshine and light winds, and so the good vertical mixing and so forth. So you're getting good dispersion in that type of situation. If you were several miles downwind, you wouldn't even, have any smoke problems with this type of scenario. This is a power plant showing again clear skies and light winds, and you can see why they call it a looping plume, because the smoke goes up and down and up and down and up, and you get good vertical mixing as well as horizontal mixing. Here's another similar example showing the up and down nature of the plume. So the neutral case is when you have either overcast skies, strong winds, or both. And here was a case where a prescribed burn was going on with clear skies and strong winds. So the strong winds is what determined that it was a neutral condition and caused this coning type plume. You can see it looks like a half of a cone as it goes downwind. And this example I showed you earlier, these were examples of coning plumes because it was cloudy and also strong winds. And so these were coning plumes that were crossing the highway. Again, certainly not as good dispersion as when you have the unstable atmosphere cases. Here's another case where have some sunshine, but also some cloudiness and strong winds. It looks like a cone as the plume ascends. Now, the stable atmosphere, which gives us the worst dispersion, we first need to talk about what a temperature inversion is, a surface radiation inversion or surface temperature inversion. When the sun begins to set, and even about an hour before the sun begins to set, the surface of the Earth starts cooling off. And that, of course, cools the layer of the air next to the ground. And then as time progresses, that cool air layer then cools the layer above it, and then that cooler air cools the air above it, and so forth. If you look at this second graph, this is height above the surface on the vertical axis. This is time here. And then this is plotting the temperature profile with height. So in mid-afternoon, what's the typical situation is the temperature decreases with height as you go further above the surface. But then once the sun begins to set, you get this layer near the ground that's been cooled off. And actually there's a layer that begins to increase in temperature as you go above the surface. And that's called the inversion layer, the temperature inversion layer. And then as the night progresses, that layer cools the air above it. And so this inversion keeps growing in height as you go through the night. So here was the top of the inversion layer at 5:15. Here was the top at 7 p.m. And then when you get to 2:30 a.m., it's gone all the way up to this level right here. So any layer that the temperature is increasing as you go above the surface, that's called an inversion. So temperature increasing with height. And the characteristic of any smoke that's caught within an inversion is that there's just no turbulence to mix it, either thermal and winds are typically very low with this type of scenario. So you get your worst dispersion when you have surface temperature inversions. And here's an example from a prescribed burn at the Wichita Mountains, probably around sunset. And you can see this that the smoke is just hanging around there doing not much of any dispersing, and that's because the surface temperature inversion has started to develop and is capturing that smoke within it and not allowing it to disperse. Here's an example. Again, this was at the marina site west of Stillwater after a prescribed burn, probably around sunset. Again, the smoke is just hanging there, doing not much of anything. Which brings up an interesting point. When you do a prescribed burn, if there's still active smoke going on, and if the forecast shows that we're going to get a temperature inversion, shortly after your prescribed burn, that smoke can still be a problem, or will be a problem if it goes into sensitive areas. So you need to sort of look at the conditions after your burn as far as the conditions for smoke dispersal. Here's an interesting diagram that shows two different scenarios. From what I see here, I can deduce that there's a surface temperature inversion. Probably the top of it's probably around this height right here. And so these smoke plumes that are caught within it are just like ribbons going downwind. They're fanning plumes. And so anybody that's downwind of these can really get smoked out. And these plumes can go for miles and still be problematic. Whereas above the inversion, these smokestacks and the smoke here, the smoke is mixing very well because they're not caught in the surface temperature inversion. And this is a picture probably an hour or so after sunrise, and the top of the inversion layer is probably right about here. And so you can see the plume, which is probably from some industrial source because it's elevated, but it's caught within the inversion, and you can see it's just like a ribbon and not doing much dispersing at all. The heating of the surface in the morning is starting to cause some thermal turbulence, which is bringing down some of that smoke into this area right here. And then the top of the smoke is escaping above the top of the inversion layer up here. So that again shows you the effect of a temperature inversion on smoke behavior. So we developed in the early 2000s what we call the Oklahoma dispersion model, which was meant to answer the questions: what are the relative downwind smoke levels near the surface where people live and drive? And interestingly, the reason we developed this initially was to address the pig odor problem in the Panhandle. Back in the early 2000s, the hog farms were proliferating in the Panhandle, and people were complaining about the odors that they were causing and so forth. And so my department head came to me and said, you need to work on a dispersion model to predict animal odor dispersion. And so we did that, but then we later converted it and used it for smoke as well. So that's kind of the interesting history of this model. But there's 6 dispersion categories ranging from very poor to excellent. They're numbered 1 to 6, and on the maps they're colored red to the greens. And if we want to put those 6 categories against these pictures here, the poor and very poor levels 1 and 2 would represent these type of scenarios. Moderately poor, moderately good would represent this type of scenario, and then good and excellent would represent this type of scenario. So general guidelines for smoke, categories 4 through 6, moderately good through excellent, which would all be greens on the maps, are good conditions for prescribed burns. Moderately poor or 3, which is beige, would be acceptable if there's no sensitive areas downwind, but you should avoid the oranges and the reds, the poor or very poor conditions, because if that smoke happens to go into a sensitive area like a highway or whatever, you could really smoke people out and cause problems. Here's what a typical dispersion condition map looks like. It shows the value of the dispersion level as well as the color code here. So this was 10 p.m. at night on May of 2017. You could see the very poor dispersion was occurring mainly in southeast Oklahoma, where the rest of the state was actually doing pretty well due to stronger wind speeds. And you can see again by the length of the arrow where the stronger wind speeds were. Here they're very low. Which brings up another point I need to address is, where is the smoke plume headed if you're doing a prescribed burn, or even, suppressing a wildfire? Can you tell by these maps where the smoke is going to be headed? Well, if the wind speed levels are, say, 5 miles an hour or greater as measured by the Mesonet site or by the forecast, then you can pretty much tell where the smoke will be headed. But in the cases where wind speeds are like under 5 miles an hour and there's clear skies, even if the Mesonet is measuring, a southeast wind at 4 miles an hour, that doesn't mean the plume is going to head toward the northwest, because what happens under those clear conditions with the surface temperature inversion is the smoke will move with what's called gravitational drainage. So the cool air that it's caught in will drain downhill. So you could basically look at the topography map around your burn and identify the low areas, and that smoke will basically go into those lower areas due to the cold air drainage that will occur, because cold air is heavier than warm air. It will drain downhill into those lower elevations. So when wind speeds are very light, you can't rely on either the forecast or Mesonet directions to tell you where the smoke is going. You would basically have to rely on topography. And of course, in southeast Oklahoma, where there's a lot of topography, ups and downs, that becomes very important. So the smoke can obviously concentrate in river valleys or low-lying areas and so forth. We also have the chart formats. For example, here's a forecast chart of the dispersion conditions going from 1 to 6, along with the wind speeds and directions. And you can see in this example here that the dispersion conditions are actually pretty good, even in the overnight hours, when typically they would become worse. But the reason for that is you can see in the overnight hours here, that the wind speeds are still pretty strong during those periods. But then once we get to this period, which is Sunday night into Monday morning, the winds really die off, and we're probably getting clear skies at that point. So the dispersion conditions become quite bad, and then they pick up again when the sun rises the next day. So let's now look at some general guidelines for prescribed burning. We've seen some of this already in the last presentation, but again, the relative humidity conditions, guidelines for prescribed burning, the wind speed guidelines. I'm not going to read it again, but this is, we'll talk about this a little bit tomorrow too. But as far as 1 and 10 hour fuels, for those of you who won't be attending tomorrow or didn't attend the Part 2 workshop, 1 hour fuels are these very fine fuels that are like the grasses, less than an 1/8 inch diameter fuels. 10 hour fuels are more on the order of a 1/2 inch diameter fuel. But these are some general guidelines for prescribed burning and also wildfire for these different size fuels. So the main point is that once they get under about 6-7% fuel moisture, containment becomes difficult. You get spot fires and you can get extreme fire behavior. Normal range for prescribed burning for those size fuels is 7 to 20% for the 1 hour fuels and 6 to 15 for the 10 hour fuels. Above that, you can get heavy smoke production. So now I want to talk about the Fire Prescription Planner, which is probably the most useful tool for those who do prescribed burning. And the link to it is one of these left menu items here. So if you click on Fire Prescription Planner, it'll take you to this first page where you see different variables listed. And then you can put in a lower limit and an upper limit for these variables. And you don't have to put both. You could just put one or the other. And now you can also specify wind directions that you want. Those of you who do prescribed burning know that typically you will have a written prescription ahead of time, and so you'll be able to enter your values into this table. And you don't have to put in all the variables, just put in the variables for which you have, a written prescription. But we list a whole bunch of variables: air temperature, relative humidity, wind speed, 1 hour rainfall, heat stress, temperature, dispersion conditions. So let me show you an example that could be used in a prescribed burn example. In the upper left here, we put in a link called Use Conditions for Beginning Burners. For those who have, little to no experience doing a burn, this automatically fills in the table with values that we consider safe. So an air temperature of 35 or higher, the reason we keep that above freezing is we don't want your water to freeze when you're trying to, control maybe a few areas that have escaped or whatever. We want your water to be able to still remain liquid form and be able to be dispersed. Relative humidity of 40% or higher, we consider that safe. Wind speeds between 5 and 15 miles an hour, no rainfall going on. Because if you're doing a burn, you really don't want it to be raining. Heat stress of 90 or less. For those who are not used to prescribed burning, heat stress can really take a toll if you're not used to it. So 90 or less is considered a safe level. Moderately good or better dispersion conditions, as we've seen, is good for burning. And then 1 hour dead fuel between 8 and 20, and 7 or higher 10-hour dead fuel moisture. So in this example, we also chose northeast through northwest winds. Let's say the landowner wanted the fire to burn in generally a southerly direction, and so winds needed to be out of these northerly quadrants. So once the criteria are put in, and this continues the table, which most people typically don't use because it's basically output variables that the fire model puts out, and that's usually not involved in any prescribed burn prescription, but we put them in there anyway. But once you put in your prescription, then you chosen your station, then you hit get data, and you get a table that looks like this. So this is every hour of the 84-hour forecast going forward in time. These are the variables for which you put in criteria, prescription criteria. And notice that for any given hour, for that any given variable, the cell is either colored green or red. If the criteria for that variable at that particular hour was met, then it's colored green, which means, good, that it was met for that hour. If a cell is colored red for a given variable for that hour, it means the criteria was not met. And in this case, you can see why it was not met, because we prescribed 5 to 15 miles an hour. And in this case, it was 16 and 17. So that didn't meet that criteria. So that's why those are colored red. So what you want based on your criteria is you want all of these to be green for that hour. Oops. So the second column where it says criteria met, if all of these are green, then this is colored green and it says yes. If one or more for that hour are colored red, then this says no. So what you then want to do is scroll down through the forecast period and see if there's windows of opportunity for your burn based on the criteria that you put in. So in this example, there were two pretty big windows of like 8 hours or so. But I highlight the second one would be the preferred one versus this. And, why is that? Well, if you look at the times for this particular window, and this was late October when the sun sets about, 6 or 7 o'clock, probably 7, but you see half of that time is in the dark. So you don't want to be doing a prescribed burn in the dark, where if you look at this time period, 9 a.m. to 4 p.m. for late October, that would be totally daylight. So this would be a good opportunity for you to do your burn, and you wouldn't want to use this time period. So hopefully you can see that. You can also use the prescribed planner for wildfire anticipation. Most people probably would not use it in that way, but just to show you how you might use it with that particular application, you could put in criteria for which you consider that you consider represent high fire danger. So like 40% or less relative humidity, or 15 miles an hour or higher, 7% 1 hour dead fuel moisture or less, burning index, again, which you don't know at this point what that means, but 40 or higher. So then you would and you typically wouldn't care about wind directions in a wildfire application. So then you would click get data, and then based on those criteria, this then would represent the window for what you consider high fire danger to be on the lookout. So, but again, most people would not use it in that application. They'd use it mainly for prescribed burning. So another thing I wanted to show you is there's these boxes down here at the bottom. It says show prescribed variables only. If you click it, that's the default, is it's already clicked. But if you, and that means that in the final table, it'll only show you those variables that you put in values for. But if you unclick it, then, and hit get data, this is the type of table you'll get. You'll get all the variables, even if you didn't prescribe variables for that. So then you can see, you know, the corresponding air temperatures and wind directions, or, you know, dispersion conditions, or whatever that you didn't put in values for. So that's kind of a nice way to see everything if you're interested. But the default is just to show, as in that case, and in this case, just to show the variables that you put in values for. So let's go over some of these questions again. What are the two major adverse impacts of smoke? Well, there's two major ones that I can think of. It's the health impact. You don't really want to breathe that smoke, particularly that particulate matter that's in the smoke. And then, of course, the visibility impacts, which can, you know, smoke out a highway and cause fatalities and things like that, highway accidents. What is an inversion layer? Well, it's a layer above the ground where temperature is increasing as you go upward. So temperature increasing with height. And what happens to smoke that's caught within it? Well, it just stays there, basically can travel many miles downwind without dispersing much at all. So you really got to be careful of those type of conditions. Which of the 6 dispersion categories from the Oklahoma model are good for prescribed burning? Well, it's the top 3, the moderately good, good, and excellent. And again, if there's no sensitive areas downwind, you could probably get away with the moderately poor category as well. How can the fire prescription planner be used for prescribed burning? We just talked about that. Before we go to answer any questions you may have, I wanted to, because I forgot this last time when we did the October workshop, so I put it before so I could definitely see it. But John Weir wanted to bring to your attention that there is a OSU online prescribed fire course, which teaches you, you know, the techniques of prescribed fire, the fire law, how to write fire prescriptions, fire effects, you know, on wildlife and all different types of things, how to make fire breaks, ignition techniques, smoke management, seasons to do your burns, which are better months to do the burns, and then also equipment. So this is a very useful course. So how do I access that course if you don't know? Well, you can go to this address here, learn.extension.okstate.edu, and it costs $20, and it gives you 120 days to complete the course. And the estimate of time for this particular course is that it would take you 8 hours of your time. And I believe there's probably quizzes and so forth after different, you know, sections of the course that you fill out. And I think to get a certificate, you have to have gotten a score of 80% or higher on the questions, but you have 120 days to complete it. So I just wanted to bring that to your attention, that it's a really good course for those of you who want to learn more about prescribed fire. Okay, so at this point, are there any questions on the slides that I presented? And then we'll go to the website.
Let's see, we had a little bit of discussion about winds related to whether wind direction was for the sustained winds and whether we recorded a direction for gusts. And I responded that the only time we would see the gusts, they're generally from the same direction unless a cold front or some kind of thunderstorm outflow moved past the site that would, you know, increase and change directions at the same time. And then there was another question about
Yeah, before you
20-foot winds.
before you go to that I just bring up something I can talk about. Yeah, in the prescription planner, as in all of our products, the wind speed is the sustained wind speed actually at 10 meters above the surface, which is 33 feet high, which is the standard meteorological level. There actually is a map of the 2-meter wind speed in the current map section if you want to see what the 2-meter height would be, which would be about what 6-7 feet above the ground. But yeah, in this prescription planner, we don't include anything about gusts. And that's why if you want to see what gusts are predicted, you could go to those National Weather Service links for your Mesonet site to see what they're predicting for the gust level. So anyway, that's my thing I wanted to add there. So.
And then somebody asked a question about 20-foot winds, and I'm not exactly sure what that was referring to, but I mentioned that we did our measurements at 10 meters, 33 feet, or 2 meters, 6 feet. So
yeah, I think that may be a forestry person talking there, but yeah, typically the old way of measuring for the National Fire Danger Rating System and other things, we're at the 20-foot level, but we don't use that in our system. We use the 33-foot or 10-meter level. And actually, I believe it's been a long time since I wrote the code, but I believe we actually have a conversion in the code itself to the 20-foot level, which we then apply to the equations for burning index and so forth. So it's indirectly taken into account, but the measurements on Mesonet are at the 10-meter level that we use.
Any other questions? Does somebody want to unmute and talk?
So on your wind gusts, hang on a second. On your wind gusts there, it's strictly at your are you reading your wind gusts on your Mesonet site at 10 foot or at 6 foot? What's it reading there? Or is it both and then taking a median?
No, the wind gusts that show on the Mesonet and on our OK Fire current products as well as past products is at the 10-meter level, which is the 33-foot height.
Okay.
Yeah, we don't measure gusts at the 2-meter level or the 7-foot level. So, any other questions?
Not at the moment, I don't think.
Let me go to the website then. I can find it. There it is. Go back to the home page. Marina data is back. That's good.
Yeah, I ran over and Trey said it was just like a temporary blip. So.
Okay. Yeah, I don't think we're having any ice storms or anything. So, so dispersion conditions are listed in this first table here. So right now they're moderately good at Stillwater and moderately good at Marina. So that would mean if you're doing a prescribed burn right now, the conditions are certainly favorable for your burn. And again, if you click on the variable name, you'll get a statewide map of the dispersion conditions. So the entire state is in good shape in terms of dispersion. So any prescribed burns that were going on now, smoke would not be a problem. Let's see what else. We can go to the animated map section, and one of the variables you can animate is also dispersion conditions and winds. So let's do that. See what's going to happen. You can see the effect of clear skies and light winds. It gets, quite bad in certain parts of the state at nighttime. But then the sun comes out and winds come up, and then it's good, tomorrow afternoon. And then look at Thursday night, not too good, most of the state. And then going into Friday afternoon, again, good conditions. And not very good Friday night into Saturday morning. And then now into Saturday afternoon. And then really bad. total red out on Saturday night. So early Sunday morning. So anyway, that's you can do that. And then also you can go to the chart table section, and one of the things that you can plot are, see, where is it? Dispersion and wind conditions. And so for Stillwater, you can see that, you know, most of the time here is actually pretty good, except for a few hours on Thursday night and some hours on Friday night. And then, of course, as we saw on Saturday night. And then these would show you the winds, corresponding wind speeds and directions. But this would be an example here where these wind speeds are like 5 miles an hour or less, that you really can't say that my smoke plume would be going, you know, to the northeast, because in that case, the smoke would be mainly following your topography, and the cold air would be draining toward the lower elevations and carry the smoke with it. So I think that's the only place on here I need to talk about where you can get these dispersion products. Why don't we now go to the Fire Prescription Planner? So a lot to talk about here. First of all, to put in values, you can either click with your mouse, or I guess put your finger there and then type in, but you can put in, you know, whatever value you want for upper limit or lower limit, and then you can put in your humidity values, whatever you want, and then wind speeds, and fill out. You would want typically moderately good or better. So moderately good would be your lower limit for dispersion. And then, you know, any of these that you wanted. And then the way you specify wind directions is you click on the sector and it turns bright orange. And so you can specify whichever sectors you want, and then to turn them off again, you just click on it again and it goes back to light orange color. Let's say you wanted to totally reset the table rather than manually erasing all these values. Well, you can hit this reset values and it'll zero everything out. And then up here is this, what I talked about earlier, use conditions for beginning burners. It automatically populates the table with values that we consider safe. So let's just use that as an example for now for Stillwater, and get the data and see if, just based on that, there's any windows of opportunity. Note that we're not taking wind directions into account. So if we scroll down, we don't see many windows of opportunity for a prescribed burn. Now, why would that possibly be? Well, here it's below 35, so that temperature-wise, so that knocks that out. This is below 40%, which is considered a safe letter, so it knocks those hours out. And here it's way too cold because the water would freeze on your burn. And here the wind speeds are above 15, so that knocks those hours out, and so forth. So you can see, you know, the reasons why there weren't any windows there. But let's try something different to see if we can get any other possibilities here. Let's relax some of these criteria, and let's say humidity of maybe 35 or higher, wind speeds maybe going up to 20. I don't think we have to worry about heat index in this cold time of year, but moderately good or better, and so forth. So let's see if we get any bigger windows with that. Now we got a little bigger window, 10 to noon, which isn't a very big window. So anyway, you can play around with this stuff at your leisure to see. Like here would have been a window, but let's see, that got kicked out because the humidity was below 35%. So anyway, that's how it works. So let me go back and show you some other things about the site. If you click on the variable name, it will, let's just do heat index as an example. It'll pop up a a box of educational text that talks about the heat index and how it's important for you as you're, doing your burn, and the caution into extreme danger levels and so forth. So all these are links to educational sections about that particular variable and how they relate to prescribed burning. So that's a nice feature that we have. Down here is where, if you want to change your station, you can click on the current station and then either the pull down menu or go to slap out, for example, and it'll change to slap out. And if you didn't want to show the prescribed variables on you can unclick that. And then let's keep the same scenario and see if there's any windows of opportunity at slap out. It's even worse there. So this is interesting. And this goes with what I told you in the last section. You notice that the fire model output is not available, and that's because the new 6-hour update just arrived, and evidently the weather products and the dispersion model is included in that have updated. But remember, I told you it takes about an hour later for the fire model update to update. So it hasn't updated yet. And so that's why if and when you see this blank area here for the fire model variables, that means the model hasn't quite finished running yet. So that was a good example to show you on that. Let's see, what else did I want to show you? Oh, also, if you keep using the same prescription and you don't want to have to keep typing it every time you do a new prescribed burn, if you click on this box, save settings as default, then and you have to go through the process and get data. But once you've done that, then every time you close your browser, come back into OK Fire, that prescription will still be there, because that's based on your cookies in your browser that it saves. So that'll always be there. So that'll permit you to not have to, type in the same prescription over and over again. So that's a nice feature that we have as well.